Okay, this is the second part on the instructional video because this system only let me record 5 minutes at a time. So we were talking about the expansion of the universe being faster with time and ideas of theoretical physicists on how to address this problem. The first again was to fill the universe with some sort of quantum field, which will be called quintessence, which is sort of a non-matter uniform field. Another was provided by Einstein when he started general relativity, because when he started general relativity and applied it to the use of the universe and cosmology, every physicist, and Einstein included, thought that the universe was static, that it should be a static space-time that never expanded nor contracted and will stay the same for all eternity. But he found out that that was impossible to do in general relativity, because if you fill it with stars and galaxies and matter, again, attractive gravity will clump space down and make it collapse. So he found out that the only way to maintain a static universe and avoid the collapse was to come up with an extra term in general relativity, which he called the cosmological constant, which is postulating that empty space in general relativity has a repulsive gravity effect that to him was to avoid the universe collapsing in on itself. When Hubble found out that the universe was indeed expanding and it was not a static space-time, Einstein thought this was his call it his major blunder in life and threw the concept away. But if you want to explain dark energy, then that's one of the proposals that's being bandied about, that there's this uh, cosmological constant, which is a property of spacetime. Another is to modify general relativity to provide that there is not matter can not only produce attractive gravity, but at large cosmological distance, the sign can reverse, and then matter will be able to, if you put them really, really far, create a small repulsive pleasure. This is called modified gravity theories, and this tries to use the gravity of objects to create this. We don't know what, if any, or another possibility is what explains this dark energy that is making the universe go faster. But it's a really terrible problem, because when you try to see the universe at larger scales, you see that the universe is flat. But to have a flat space-time, you need a certain amount of matter energy, which is called the critical density, for this to come about. Now, by looking at all the galaxies we can see, we know that we are really, really, really far away from that critical level. We cannot be having a flat space-time, and our universe should be an open universe, because we have very, 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 very little matter compared to what is needed in this critical density. Now we know that the matter we see is only a small part, because there's all this other matter called dark matter, which again is a concept postulated to explain why galaxies rotate so fast and don't break out, and to explain motions of clusters of galaxies and baryonic acoustic uh, oscillations that say that there's at least 10 to 60 times more matter than we can see. But even if that were the case, we'll still be like in 30% of the critical density. So to have uh, flat spacetime as we see from data in the cosmic background, microwave background, then it's postulated that this dark energy must fill whatever remains, which is that it must be about 70% of all the energy content in the universe. And that's really mysterious, because, again, the ideas of trying to postulate a field or a cosmological constant or a gravity change to make it of this exact size to make the universe uh, flat will be a very difficult problem. Thank you. Bye.